Okay, ladies and gentlemen, today we're going to take a few minutes and we're going to delve into the idea of scatter plots. You were asked to read the section in the textbook on scatter plots as well as explore several exercises. We will be going and reviewing those exercises in the process of these notes. So as a scatter plot, as I hope you can recall from your reading or your notes you took for the reading, show the relationship between two quantitative variables. This type of plot is going to take a different look from many of the previous plots we've looked at. Previous plots we've looked at have all dealt with generally one variable. We've looked at box plots and stem and leaf plots, which, while quantitative, only dealt with one variable. Scatter plots require two variables: a response variable and an explanatory variable. Now, the response variable, you recall, can be thought of, though it's not exactly the same, but can be thought of as the dependent variable. The variable we're looking for an explanation. The explanatory variables, they're going to measure the outcome. They are measuring an outcome. So they're looking to provide us, end result information. The explanatory variable can be thought of and is very similar to the independent variable. And this variable is designed to help us predict or explain changes in the response variable. So even though these variables are, we can think of them in a way as the independent dependent variable, they are a little bit different. Some scenarios, it's very easy to see which one is the explanatory and which one is the response variable. There are other scenarios, can't seem to speak right now, that either one of them can take that role. So let's look at some examples. These all come from your textbook. And we're going to try to explain which is our explanatory variable and which is our response variable. So if we're looking at the amount of time studying for a statistics exam and the grade on the exam. So if we look inside of this question, we can see amount of time studying for the exam is one variable. Okay, so there's our first variable. And then the grade on the exam is the second variable. Now, two variables, think logically, does one of them come before the other? Logically, does one come before the other? Well, normally you study for an exam before you take the exam. So study the amount of time will be our explanatory variable. Is the explanatory. I'm going to erase that a little bit, rewrite it. Oh, I didn't take my eraser. Okay, so the amount of time is going to be the explanatory variable. And the grade is our response variable. Now, the response variable, as said, measures an outcome. And a grade does measure an outcome. It measures your performance on the exam. And it's logical, and you probably have some experience, that the more you study, the more likely you're going to perform better on the exam. And we often will talk about that. I know you've probably had teachers that have talked about, how long did you study for the exam? How did you perform on it? So one leads, in this case, more studying. Generally leads to better grade. So studying is helping to predict the grade. So let's look at the second example, the yield of corn bushels per acre in the amount of rain. So if we're looking at this example again, we got the yield of corn in bushels per acre is our one variable, and the amount of rain in the second variable. Now think, you've probably lived through a time of little rain, and we call that a drought. And then we tend to struggle to get grass to grow, water rationing, and so forth. But when rain tends to be plentiful, plants tend to grow more and flourish and are very lush. So we can see the yield of corn. Yield of corn is our response variable. It happens because of the amount of rain is our explanatory. Now, even though we're talking about association here, do not mix up the fact that something's associated with cause and effect. In this particular example, the amount of rain does cause the better yield, but that's not necessarily the case in all situations. Don't mix up association with cause and effect. We'll look into the idea of cause and effect later on. So now if we look at the last example, number 3, we're talking about the arm span and the height of seniors. Oh, my pen is not working. Oh, there we go. So in this case, our two variables, we have arm span. Oh, that's weird. Hang on a moment. Let's erase some of this. Okay, so we have arm span and we have height. Arm span will be our first variable. Height is our second variable. Now, there's a relationship. Taller people generally have longer arm spans. Longer arm spans generally, we've heard of taller people. So both of them can be predictive of the other. Both can be predictive of the other. Unlike the previous example, corn, just because you got a good yield of corn doesn't mean there was a lot of rain. There are other ways to provide water needed for corn to grow that wouldn't be rain. But in this case, arm span and height, taller people generally have longer arm spans. So in this case, because both of them can be predictive of the other, either one could be explanatory, either one could be the response. This is the case that not one of them predicts the other specifically. So we've got to be careful of that. So let's dive into scatterplot a little bit more in detail. So here we have a scenario. It's talking about the 40-yard dash time measured in seconds and long jump distances measured in inches for a small class of 12 students. Okay, so first we got to look at what do we know of these dash time, long jump, which is the explanatory and which is the response. Well, if you've ever ran, you think about it, there's a standing jump and then there's the running up and taking a jump. Generally speaking, running provides you more power, and you tend to jump faster. So you further. So in this case, we're going to look at our explanatory variable is going to be the dash time, and our response variable will be the long jump. What we're saying here is that the faster you go, perhaps the faster you go, the more you could jump. All right, so we've identified which one is our explanatory, and the explanatory variable is the one that goes on the x-axis, and the response variable goes on the y-axis, which again relates back to an earlier concept of dependent versus independent. So next we want to label and scale our axes. So we know I'm going to put dash time on the x-axis. They look like they run from 5 to 7. So we can go, probably cheat a little bit. I'm going to go ahead and put a break in here. So then I could go 5. I'm going to change to black. So do these in black. 5, 1, 2, 3, 4. 6, 1, 2, 3, 4. 8, 1, 2, 3, 4. 9, 1, 2, 3, 4. 10. Okay, so I'm going to use the break just so that I can skip over and just look at 5 through 10, and I can count by quarters. Now, when we look the other way, it's going anywhere from 90 to 173. So I think we can get away with probably 10. $40, 60, 80. Oh, it's not going to count it. We're going to have to go with it. Oh, I didn't do that right. This one should be 80, 120, 160. Okay, that should be good. Oh, no, we go all the way to 184. So I'm going to go ahead and count by 25. So it should be 50, 100, 150. It is perfectly okay to scale. Realize you don't have enough and go back. So if we label our axes, this one is going to be dash time, which is in seconds. This is going to be long jump. Which is in inches. Okay, so we're going to plot each of these variables like they're ordered pairs. So 5.41 and 171. There's 175, so we're probably a little bit below that. Oh, let's do this again. Okay, and then we've got 5 and 184. So 5.05, so 5 and 184, so that's 175, 197. So I'm guessing that's probably okay. 7 and 90. Wow, just realized I scaled that wrong. So let me fix that scale before I get too far. That's just going to be in red. 7, 8, 9. Okay, so 7, 90. Okay, a little bit more 7, but only 65. So that's 75. There. 6 and 3/4 roughly, and 130. 5. Okay, and 130. Oh, whoops. Are you paying attention? Excuse me. 6.73 goes with 78. 5 and 130. Oh wait, still doing that wrong. 6 and 78. 5 and 130. 5.78 and 173. 6.31 and 173. 6.4 and 92. 6.5 and 139. 6.8 and 120. And I got this 7.25 and 110. All right, and there we have our scatter plot. And we should start to see that some patterns and things we can observe, and we're going to come back to look at that. Let's try another example. This time let's look at what was number 5 from the textbook. I've included the chart here. I didn't quite include all of them just because I didn't have the room, but we'll be able to get the gist of this from this. So, whereas how does fuel consumption of a car change as its speed increases? So just from the question alone, we can see that the explanatory variable is going to be speed, because we want to know if the speed increases, how does that affect the gas change? And this is going to be fuel consumption. Let's go ahead and look at our axes. Switch to our black pen. Okay, so that's going from 10 to 150 in speed. Let's write it down here. Twenty, 40, 60, 80, 100. So 20, 40, 60, 80, 100, 120, 140, 160. Have a little bit more than we need, but should be okay. And this one looks like our speeds go, our fuel consumption goes from anywhere from 7 to 21. So probably do this counting. 4, 6, 8, 10, 12, 16, 18, 20. So that's 4. Okay. Okay, so let's look at what we got. For 10, we got 21. That one's well off the graph, but we're going to go with it anyways. So this is 20, so 10 and 21, probably somewhere up there. And we've got 30 and 10, 40 and 8, 50 and 7, 70, 6.3, 80 and almost 7, 100 and 8.25, 110 and 9, 120, 10, 130, almost to 11, 140 and almost to 12, and 150 is almost to 13. So this one has a very different shape, but don't forget to label your axes. So this is fuel. That's in liters per 100 kilometers. And here we have speed in kilometers per hour. So as we can see, this one starts out burning a lot of fuel if not going anywhere, but as you start to accelerate, the engine becomes more efficient. It looks like it comes down, and then as you get to a certain point and you want to go faster, then it starts consuming fuel again. And that brings us to the idea of describing a scatter plot. Just like we did GoSox for other quantitative displays, we're going to describe here the scatter plot. And there's 4 characteristics. There's direction, form, strength, and outliers. So going back, let's look at direction. Scatter plot can show direction is either positive association, negative association, or no association. In a positive association, as x increases, so as x increases, positive says as x increases, y increases. So both variables are increasing. That's what we have here. This one is positive. And we can see that as we go further along the x's, we're going further up the y's. Now, in negative association, exact opposite. As x increases, we can see the pattern that y is decreasing. Which is our second example here. As we're going further to the right, we can see that the dots are becoming lesser and lesser on the y-axis. So this is negative. Now, no association, there's no pattern. No pattern. This is where you get the idea of a scattered plot most often. Points are scattered. And here we have no association. So that's the idea of direction. Which way is the data going? As the horizontal variable increases, x increases, what is y doing? If y is doing the same, it's positive. If y is doing the opposite, it's negative. And if y is just all over the place, there is no association. Okay? So let's talk about form. Form refers to the shape of the plot, more the shape. A linear form means the points. In a linear point, the points are forming a line. The strength of that line we're going to discuss later, but they're forming a line. And if we look here, I'm going to go to color, we can see that in this first example, all the points are arranged along that line, so this is going to be linear. Even when we look at the second example, it still has this line going through it. It's not as strong, the points are a little spread out from it, but there's still the general sense of a line. So this one is going to be linear as well. Now if we look at this third D, we'll call this one D, we don't see a line. We trace this one, it's more going like this. Dots are following that curve. So this is said to be non-linear. But beware, there's something like example C, where there's really no pattern. There's no way I could start and show the curve. So this one has no form. So going back to our point, a linear form forms a line. A nonlinear form, the points form a curve, not a line. These were called straight curves, but a line. This one is a nonlinear because it's forming a curve. Be aware, though, no form is neither linear nor nonlinear. And moving on, the strength. Strength deals with how close to that shape we just talked about. This is how close are the points to the shape. How close are those points to the shape that you're seeing? Okay, weak association, the shape is there. The shape is there. The points are spread out. Are spread much greater or much less. Okay, moderate association, shape is there. Points are closer to that curve. Now, a strong association, shape is very clear. Points are close. So if we're looking at the other examples, and we want to look at the strength, the closer the shape, if I want to order these, put a 1 at the least, the weakest one, the one that's hard to see. This one's going to be our number 1. That shape, those points, it's even hard to even see if there's a shape. If we start to get stronger, I mean, this is very weak. Maybe not even there. Very weak. But as we start to look at stronger, we start to see this one's a little bit better of a line. Even this one's better of a line. Okay, I still think those are weak. Those points are still spread out, but they are still weak. And weak and moderate, it could be a judgment call. Now, and I would guess that this one is probably 2. Actually, this one I would call 3, and this one would be our 2. This one just appears, the one I labeled 3 down here in the lower corner, I think it's a little tighter. But if we continue to look, I think this one is going to be our 4. We see again a much tighter line, so we're starting to look moderate. And our last 2 are probably what we're getting. We can clearly see the line going on in the last 2. These are both strong, because the line is very apparent. Okay, this one may even be thought to be very strong. This is our 5th one, getting stronger, and this one is our 6th one. So if we number this, 1 is the weakest and 6 is the strongest, but you can see as the points get tighter to that line. Our last idea is outliers. Outliers really are no different than they were when we talked about other quantity displays. There are points that do not fit the overall pattern. We look at our first example here. We can see basically this line through here. The black dots are pretty close. They help us fit this shape. But the 2 red dots are our outliers. These are our outliers. They really don't fit in the shape. And we're seeing this one. This one is almost even non-linear. A little bit more of a curve. So it's probably non-linear. But this one was linear. This one's probably stronger, just strong. This one's probably moderate. But even this one has an outlier right here. It's not really in the shape. It's far off, and if we tried to include it, it would really mess with it. So this is our outlier. So just like in the other quantitative plots, outliers are points that look out of place. So now that we've talked about these four shapes, we're going to go back to our two plots. Go back to this plot first. And let's describe this shape. So what direction does it have? Well, if I go to the right, we're expecting that it's falling down. So this one has a negative association. The points are going down. They're decreasing on the y-axis as the x-axis is increasing. If we were to sketch our line through it, just because we can, and we can see, it does really start to follow that linear shape, but I don't think it is very strong. The points are pretty spread out. So we're going to call this one a moderate. It's a moderate association, and it is definitely linear. But I don't see any points that are away from that general shape. So we'll go ahead and say there are no outliers. Okay, so negative, it is going down. Moderate, the points are starting to getting tight and close. It's definitely aligned, so it's linear. And there's no weird shapes. Points. So let's look at number 5. Number 5, we can't even say it's positive or negative because you've got it going down and then going up. But this one is a nonlinear form. Nonlinear form because if we trace this one, it's got this curve. That is definitely not a line. But I can almost trace right through those points without wavering. So this one is definitely strong. Association. As for positive, negative, it is nonlinear, so it's very hard to tell positive or negative, and so it's neither positive nor negative. But there is this point up here, which could be an outlier. It might not be, it just is kind of stretched out. The rest of them would tend to be a lot closer, so that one will definitely be an outlier. So I hope, ladies and gentlemen, you can see this idea. Remember, as you go to look at the practice activities, you've got 2 of them. One is the StatsMedic worksheet that you will be expected to submit. You can do that digitally. The other one's the practice set. Either way, you can also turn the StatsMedic sheet in hard copy when you come to your next class. Either way, you've got both the practice set and the worksheet. Make sure you come to class, your next class, ready to discuss this, have any questions to have them addressed. Don't come in with nothing. Make sure you've got your notes and an effort of trying to look at this data. So again, remember, we're talking about this describing direction, form, strength, and outliers. I hope, ladies and gentlemen, that is scatter plots. We will look at them a little bit more in detail come the next class. Thank you very much.